Good day, guys. Darian Giuseppe here, back again with another video for the Key Concept series. What we're going to look at today is the roots of polynomials, more specifically, when a polynomial has complex roots. So let's get straight into it. This is the roots of polynomials. And just to talk about it for a second, whenever a polynomial has, or the rule is that whenever a polynomial has a complex root, then the root occurs in conjugate pairs, if and only if the coefficients of the polynomial are real. That's the key. So that's basically the rule. That is in a nutshell what we need to, or that is a key concept for today's video. That's what we need to keep in mind. So what I just said is basically this. This is the rule here. So this is it in a general sense here. So we have let p subscript n of z. Let me just change my color. P subscript n of z be equal to this. And this is just basically the general form of a polynomial here, where these are the coefficients, right, of the polynomials, of the polynomial. And these are your variables here. And these are the powers. So the powers belong to the set of positive integers. That's basically what they say in there. So don't get confused by that first line. Do not get confused by it. Then we say that if you let the polynomial equal to 0, or if that polynomial equal to 0 has complex roots, then the roots will occur in conjugate pairs, if and only if the coefficients of p subscript n of z are real. And these are the coefficients. These coefficients need to be real. So that is basically what we're saying is, let's consider a polynomial here. And just to put this in the exam, for the polynomial, the highest degree of the polynomial, and when I say the degree is the power that they would possibly give you, is like to the power of 4, but usually it's just to the power of 3. So let's just consider a polynomial, this polynomial, right? But it's just a quadratic type polynomial. And what they're saying is that if this polynomial has a root, alpha is equal to 2 plus I, if that's the root of this polynomial. That is not necessarily the root, right? This is just a hypothetical scenario. If that is the root, what the rule here is saying is, if this is a root of this here, right? Or because this is a root of this, and the polynomial has real coefficients, the 2, 4, and the 2 here are real, then the roots should occur in conjugate pairs based off of this rule here. So then it implies that alpha bar, which is 2 minus I, is also a root. And that's it. That's basically the rule that you need to make sure you know. And that rule is, if you have a polynomial that has a complex root, the roots occur in conjugate pairs, if and only if these coefficients here are real. If they're not real, then we cannot apply this rule here. If they're real, then we could go safely ahead and apply the rule that the roots occur in conjugate pairs. And that's it for this video. Pretty straightforward, pretty simple. There's a rule that will come up. Feel free, guys, to share this to somebody that you feel it would assist in exam preparation. Like and subscribe to the channel, and see you in the next video.